So thanks for an introduction. Me, Karlijn, and Sati, maybe you can just quickly wave. We'll tell you about what we do here at Booking.com in the machine translations team. Maybe you know, actually, so Booking is originally a Dutch company, but actually right now we're available in 43 different languages. And this is also what our team actually tries to help with. So the dream of our team is we would be able to translate like every piece of text from any language into any other languages. And that's so in a nice vision statement, we want to empower people to experience the world without any language barrier. So what we'll talk about today, how we got a little step closer, I guess, to this dream by doing transfer learning, both across domains and across different languages. And we'll keep the kind of theory minimum, but we do want to show you a little bit. For the people that are desperately thinking like, oh, what was transfer learning again? I'm gonna quote Wikipedia, which says transfer learning is a research problem in machine learning that focuses on storing knowledge gained while solving one problem, or maybe on one domain, and applying it to a different but related problem. So we'll see that both across different domains and across languages. Just keep this in mind, this is the main theme. Some context. The machine translation team, we exist for, I think, around 3 years. And what we used to focus on really is translating the property descriptions. So we would get text like the one you see here. The house is only a 10-minute journey from Newcastle Center and 5 minutes from the Metro Center shopping complex. And you can see this really a specific kind of text. And we would always translate from English into any of these, I think it's 11 languages. I don't know if there's any Spanish-speaking people in the room. Can they check this translation, maybe? Yeah, is it good? So this is what our model used to do. Yeah, okay. I see a thumbs up, that's nice. Actually the models that we used to train then, we trained it just on this in-house data set of property descriptions. So it was just trained on this very specific domain. And actually it did really well on that domain. But now comes, we had a new challenge that we also want to translate a lot of all the user-generated content that we get. And an example of that is the reviews that we get. So let's say I'm Dutch, so if I would write a review, I'd probably write it in Dutch. But actually we want all users of the website to be able to understand what I said. So I might write something maybe in English. Location is very far from the city center. The breakfast with some spelling mistake was poor. And then, maybe we can have the Spanish speaker check again. Do you think, I mean, I can actually, so if we do that through Google Translate, we can actually see that it translated to, it's very close to the center of the city. And the restaurant was Pomo, some random word. So what you can see here is that actually it was just trained on these property descriptions, which are always very positive. So like no matter what it sees, even if it sees very negative text, it will just produce something positive. So it's close to the center of the city. And also it is not able to understand this spelling mistake, although we as humans can kind of clearly see that this was meant to be breakfast. So what should we do? So then, we get back to this. Maybe we can learn from different domains in order to be able to also translate reviews well. And I should add to that we don't have, so we used to have for property descriptions, we had a big in-house data set of parallel sentences. So we had really good training data. But for reviews, we had a really small training set, so not enough to just simply train on that. So what we decided to try is we will train a model on a lot of, we will call it multi-domain data. Basically, this is open source data, like TED Talks, UN documents translated, basically everything that we could find. And the idea would be to train a first model, so multi-domain model, just on that. And then we would be able to fine-tune. So it means like do a couple of rounds of final training just on this specific domain that we would be interested in. So we could have a general model, and then we could fine-tune it maybe on property descriptions or on the reviews, maybe even customer service emails, or anything that we would have just a small data set on. Yeah, just to make it maybe a bit more concrete, this is what we actually had. So for English to Spanish, we had a lot of property description training data, 15 million parallel sentences, and for reviews, again, way less, too few to train a model on itself. So we added a lot of the open source data, and in this way we could kind of increase our data set from this 15 million to 96 million parallel sentences. But it's not so clear that, so we tried to translate reviews, so how much would actually legal document translations, TED Talks, yeah, it's not exactly the same, so therefore transfer learning, so learning on a different domain and trying to apply it to the domain that we're actually interested in. Yeah, to give you some idea, so the first two examples we already saw, and the kind of data that we add is, yeah, maybe movie subtitles, hi Uncle Howard, are you mad? Please don't be mad. Some legal text, you've requested a debate on this subject in the course of the next few days during this part session. It can be very complicated thing, the ocean. So it's not super related to reviews, but yeah, we're just gonna throw it all in and see if we can learn from it anyway. And the answer is yes. So we want to show you now actually the results of this, just this multi-domain model. So it's not actually even fine-tuned yet for the reviews. These are the results that we have a small sample that is checked by humans, and they basically say, is this okay to go online or not? And the percentage tells you how much of this sample is okay to go online. And on this old property description model, so just trained on the very narrow domain, so on property descriptions, it did really well. Like 99% was okay to go online. But on positive reviews, and especially on negative reviews, this wasn't good enough for us. On negative reviews, it got only 79%. But now, in contrast, we will see how it did on how the multi-domain model actually did, so trained on all this data. We see that it got a little bit worse on property descriptions, which kind of makes sense. We add a lot of non-related stuff there. It wasn't fine-tuned yet on property descriptions. But we got a big gain on both the positive reviews and the negative reviews, which we get up to 90.4%. So yeah, we were quite happy. So yeah, I also want to show you a little bit of theory of, okay, how do we really do this? And let's just look at this, let's say, translation. We want to translate from this Spanish, hola PyData, to hello PyData. And then what we do is we will start actually by splitting this source sentence, so the Spanish sentence, into subwords. So we provide, in the beginning, we we kind of decide what are the subwords that we can use. So it's actually a dictionary about 30,000 subwords. And the thing to note here is that maybe if you did other NLP-related tasks, such as maybe sentiment classification or maybe any classification task on text, then what we usually do is actually just use the word themselves as features, and if sometimes there's an unknown word that you never saw in the training data, that's fine. The model would just ignore it. But for translation, you can't, if you kind of miss a word, then you're never going to be able to translate well. So that's why we have this idea of subwords that in the worst case, if it never saw anything of the word before, it could actually fall back to the character level subwords. So usually then the model would be able to copy or at least still make some sense of it. And we would actually never have unknown tokens. The kind of models that we use is encoder-decoder models. So the job of the encoder is to understand the source. So we feed it token by token. And the job of the decoder is to kind of take that information and to one by one spit out the target tokens. So in this case, this is what it's supposed to do. So now that you know a little bit how this actually works, we also want to show some actual translations of this multi-domain model that we built. I just want to show one thing in between, which is the specific library that we're using here at Booking. It's OpenNMT, so for neural machine translation. It has Python binding, so we're on the right conference, I guess. So it does sequence to sequence mapping, which is a thing that we use, but actually it also has other, let's say, options. So maybe classification or sequence tagging. It supports many architectures, RNN, convolutional neural networks. The one that we're using is transformer, so another kind of encoder-decoder architecture. And the nice thing about it is that it's based on TensorFlow, so it allows multi-GPU training. And also you have these nice monitoring on TensorBoard kind of for free. So now comes the demo. I was so excited about it that I already jumped to it. So what we want to show you is kind of even a bit more difficult task. We will translate using our English to Spanish model. So maybe from the house to la casa. And then we also have the model in the reverse direction, which will translate from Spanish to English. So we hope that it actually goes from the house to la casa back to the house. Or maybe it could give a synonym of the house. So because it just should understand that it's the house, but it doesn't have to give back the exact word. So yeah, let's come back to this example where I hope we still remember that in the old case, it would translate to something positive and it doesn't understand the spelling mistake. Now what we see actually is that with this double translation, now it actually does understand location very far from the city center, and it kind of corrected the spelling mistake. Breakfast was very poor. It just actually makes it, it's not just poor, but very poor. But this would be considered, a good translation. So this is definitely way better than what we had before. So this is actually Sati's work. He wanted to take it even to the more extreme. This is what he kind of a demo example, where this person might be very lazy. He doesn't want to type any syllables. And also the second sentence, I think only half of the tokens actually is good, makes some sense. But still, as human, we can understand what it says here. So ideally, we would have a model also just being able to translate this. This is the nice example, of course, that actually this is what our model did, like double translate. It did understand it, and it even corrected like this source sentence. Wow. So at least Sati is impressed. That's good. I have one more example, which is I can't work today because I'm under the weather, which is also quite difficult for the model because this is some kind of a saying. And even here, like going from Spanish back to English, it translates it to the more literal thing, I can't work today because I'm sick. So we can see that it really pays off to train on a lot of general data. It now really understands many more concepts than just property descriptions. So here, actually, I want to kind of ask you what could go wrong. This is great, and I will hand over to Sati to kind of, maybe touch upon that.
Make things wrong, yeah. So two things while we transfer this. One is, this was amazing. And two is, this was also a little bit of cheating. Let's see why this is a little bit of cheating. So we said in the very beginning that we are going to cover all 43 languages. And so far, what we have looked at is our best case scenario. We showed you how well things can work in case of Spanish. But Spanish is a language for which we had largest available of sentence pairs to train on. We had 96 million sentences with English. And we could train a good translation model, which is also of a comparable amount of size with 100 million parameters. That was somehow doable. But what about the rest of the 43 languages? They wouldn't have so much data. What about this extreme? A language like Ukrainian. We would only have, going open source and whatever, we would only have 3 million sentence pairs to train with English on. This is much of a worst case than what we have been looking at so far. So 30 times less training data and 30 times, and assuming that Ukrainian is no easier than Spanish, then the model capacity should still remain the same. So 30 times less training samples versus the model that we want to train, we want to learn. So seems like a difficult task now. Let's see for ourselves. So now we are going to focus on Ukrainian instead of Spanish. And we are going to look at Ukrainian to English translation model. Trained exactly the same way, the Spanish way, and let's see if it works. So the x-axis here is the training steps while we train the model in increments of 40,000 steps. But I do zoom in on the first 40,000 because a lot of interesting things happen in those first 40,000 steps. So that timeline is zoomed in. The y-axis is some measure of loss. So in these kind of tasks, this is sequence level log loss. But for what it matters, for a good model, the loss value should be low. Let's see what happens when we train Ukrainian to English. The model gets really good after 40,000 steps or a couple of hours, and then it worsens or overfits. Now, in comparison, the Spanish model kept on getting better and better and better on the same hardware for 4 days. So maybe the model didn't learn enough. Maybe something did not happen adequately. Let's see. This is a Ukrainian review that we want to translate now using the model. Can I ask if there is a native Ukrainian speaker? So it is a small language. Can I ask if there is a Russian speaker? Wonderful. Can you roughly interpret what this means in English for us?
Yeah, it says that they are not here, and there's a heating up with the air conditioning. Oh, you have to take shoes and a pajama.
So we got something. I don't think if this review is helpful right now. But this is what the machine learns to translate. They are not here, air conditioning is ready. Get warm troops and slippers. Something is going wrong in the language structure on the first side and about this word troops on the second side. There is hope. The hope comes from transfer learning. The hope comes from the fact, what we saw just now, that Ukrainian to English can possibly benefit from Russian to English model because Russia to English, we still have much more data. And that hope hinges on a couple of facts. One is, for both these translation tasks, English was a common part. Half of the model can actually really benefit because it is common. The other language, it definitely seemed similar just now, the two languages, Russian and Ukrainian. So maybe if we train one model well, that could somehow benefit the other model. We need to figure out how we are going to transfer this knowledge, but there is hope. The rest of the talk is going to focus about how we bring this knowledge from one model to another. A method popularized in computer vision is to initialize a model with another model that you have built already, which is working well. What this means in our context is, let's train a Russian to English translation model, which takes in Russian sentences and has already learned to translate it into English. And let's use its weights to initialize the weights of a Ukrainian to English translation model. So all the weights just copy pasted. And then we start the training of Ukrainian to English translation model on its limited data. So it has some kind of head start now. Of course, one catch here is, of course, Ukrainian vocabulary is going to be different. So some of those things, those embeddings and words are going to still be initialized at random. How does this work out? Now we did two tests. Not only do we initialize the Ukrainian with the Russian, we actually also initialize Ukrainian with the French, the second test. Now this test is really important for us because while Russian is a natural language of choice for Ukrainian, we also want to scale our ideas to the rest 43 languages, and we may not have a tight pair like Ukrainian-Russian going forward. So we also test with initializing with a not so similar language. Results? We get better model in both the cases. Language similarity seems intuitive, helps a little further, but it is not necessary, and this is good news. What happens to the translation? Okay, partly fixed. We have pajamas now. But the language structure is probably still poor. And it seemed like it is also poor because in the source itself, in the Ukrainian text itself, the language structure is also a little complex. So going forward, there is one thing, although, about this approach that I personally don't like. It's very one-at-a-time approach. You need one good model to begin with to benefit another one model at a time, and the benefit is in one direction only. Couldn't Russian model have benefited from Ukrainian? Couldn't there have been many languages benefiting from Russian model all in the same go? That would be good for the long tail of 43 languages. So, joint learning. The idea is one model trained jointly to perform many translation tasks. So, Russian to English, Ukrainian to English, and whatever to English that you want to throw in, you throw in. Same model learns all these translation tasks. So, there is more data being thrown in, the data augmentation perspective of benefit, and there are many tasks being learned, many losses being minimized. The model learns to translate Russian to English and Ukrainian to English, etc. So the multitask learning kind of philosophy and advantage also coming in. This is a little bit of detail, doesn't matter too much. What matters is we are training one model to do all these tasks, showing all those data points. And this time we do 3 tests. The tests are shown in green. We are going to train Ukrainian with Russian, of course a natural choice, with French, of course we discussed this earlier, and this time we are also going to throw both of them, Russian and joint, because we want to see if the potential is not just 2 models at a time, but many things being trained together. So we want to expand how many things can be trained together. So now we have 3 in that set, Ukrainian, Russian, and French. Of course, we have some reference points from what worked for us earlier, the initialization methods, and not doing anything method. One thing I would highlight is a key thing to note here is the moment we start mixing, doing this joint training, all of a sudden we have much more data coming from Russian language than coming from Ukrainian to English language pairs. So 3 million versus 50 million. Do we really want the training, the joint training, to be overwhelmed by and dominated by Russian to English translations? Maybe not. And the easiest way to handle that is this upsampling parameter, that we should upsample and boost, just duplicate those examples of Ukrainian to English to balance them out. That is what we do. Somebody else could see it as a hyperparameter and they could tune this mixing ratios. We don't do that in the next result that we see now. Oh, by the way, any intuition which one is going to work best out of the 3 tests? The both. If the both works well, I think it is good news. So that's what I'm also hoping for, because then we can think of training 9 languages together. And it does. So both in blue versus Russian and French, everything is working, but both does not do worse than just Russian alone, which is good news. The other thing I would add is versus what we got earlier, this is going to work much slower. It takes its own time. Versus initialization method, which converged really fast, which got best really soon. And that makes sense. In initialization, what are we doing? We are giving the Ukrainian model the initial boost, the initial head start with whatever it knew from the Russian English model about English and about Russian, and that's all. Over here, at the very beginning, the model knew neither Russian, nor English, nor Ukrainian. So it is this interplay happening over the course of the training where model learns something about Russian that benefits Ukrainian, it learns something about Ukrainian that benefits Russian. So of course joint training takes its own time, but then it does get to something really nice. What happens to the translation? I think it works. The last one. There is no air conditioning, no heating, so take warm pajamas and slippers. Now, of course, we are, like any demo, we are doing some cherry picking, but we have also done human evaluation results, and yes, this is the rank ordering of goodness of these methods. To conclude, this has been a long journey, no transfer learning. Karlijn showed us that when we trained Spanish on our own data, it didn't do so well. We naturally tried to borrow the knowledge from other domains, movie subtitles, etc. And we saw the Spanish model got amazingly robust even to spelling mistakes and extreme mistakes. But then the moment we came to long tail of languages, Ukrainian, that wasn't adequate. So we had to go further to fetch the knowledge from something even farther. We had to fetch the knowledge from other translation tasks, other languages. This is what we saw for Ukrainian. We saw 2 popular methods of transfer learning that you're going to see not just in machine translation, but also outside, which is one is to initialize the model with something that we think can benefit, and the other one is to train things jointly. What we saw is both methods work, but jointly was slower, but even better. At this point, we can take questions.